As we continue in part A of section 5.4, we're given another free response question, and we have a function g of x defined as an integral. And in part A, we're asked to find g of 4, which is really the area under the graph from 1 to 4. And my function is f of t dt, which is going to be the area from 1 to 4. Well, notice I have a triangle above and a triangle below that cancels out. So really, the area of this trapezoid is going to be this answer. So the area of the trapezoid is 1/2, the base is 1, the left height is 4, the right height is 1, and this is going to be 5/2. To find g of -2, that's going to be the integral from 1 to -2 of f of t dt, which is really the negative of the integral from -2 to 1 of f of t dt. Remember, when we're calculating area, we should put the smaller limit on the bottom. So we're really looking for the area of this triangle, which, if I work that out, is going to be the negative of 1/2, the base is 3, and the height is 4. That ends up being -6. Okay, in part B of this question, we are asked to find the instantaneous rate change of g with respect to x at x equals 1. Well, instantaneous rate change just means the derivative of g. So now I'm taking the derivative of a function defined as an integral. So the derivative of this integral, because it's going from a constant to x, I just drop the x in place of the t. And now they want us to evaluate this when x is 1. So this is the graph of f, which is really the graph of g prime. So at 1, that value is 4. Okay, in part C, they're asking us to find the absolute minimum value on the closed interval. Well, again, if we take a look at this graph, here again, this is the graph of g prime. Notice that there are no critical numbers where the derivative changes from positive or from negative to positive. So therefore, my absolute min has to be at an endpoint. So we could say, since graph of the derivative does not change from negative to positive, the absolute min must occur at an endpoint. And we evaluated those endpoints in part A, and we do have an absolute min at g of -2, which worked out to be -6. And finally, in part D, we're asked or told that the second derivative is not defined at x equals 1 or x equals 2. How many of these values of x coordinates are points of inflection on the graph of g? Justify your answer. Well, at x equals 1 and x equals 2, my second derivative is undefined. But at 1, my g prime is changing from increasing to decreasing. So we would say that at x equals 1 is an inflection point. Why? Because g prime changes from increasing to decreasing at x equals 1. And that would be the only candidate. You could state that x equals 2 is not an inflection point because g prime does not change from decreasing to increasing. But it only asks you to identify the inflection point. So the only inflection point is going to be at x equals 1. Okay, in our next example, we're looking at a 2003 exam. Again, we have a function defined as an integral. And in part A, we are asked to find g of 3. So that's the area under the graph from 2 to 3 of f of t dt. And 2 to 3 is simply going to be this trapezoid. So to figure out g of 3, this is going to be 1/2. The base is 1. My left height is 4. My right height is 2. So this ends up being 6 times 1/2, which is going to be 3. Now, if I wanted to find g prime of 3, that's going to be the derivative of my function g. Well, the derivative of g is g prime. And because I'm going from a constant x, the derivative of my integral is simply f of x. So g prime of 3 is really equal to f of 3. So at 3, the value of f is 2. So really, this is g prime's graph, or the graph of f. The next one is g double prime of 3, which is going to be the slope of the tangent line at 3. And if we were to calculate that slope using rise over run, I'm going down 2 over 1. The slope would be -2. All right, in part B, we are asked to find the average rate of change on g from 0 to 3. So remember, average rate of change is the function at the right endpoint minus the function at the left endpoint over 3 minus 0. And we found g of 3 in part A to be 3. To find g of 0, that would be the integral from 2 to 0 of f of t, f of t dt, which would be equal to the negative from 0 to 2 of f of t dt. So from 0 to 2, I have a triangle, and it's 1/2, the base is 2, and the height is 4. So it's going to be the negative of 1/2, the base is 2, and the height is 4. So that ends up being -4. So 3 minus g of 0 is -4 over 3. So the average value, or average rate of change, sorry, is 7 over 3. So in question C, it says, for how many values of C is g prime of C equal to the average rate change in part C, in part B? Okay, well, we know that the average rate change is 7/3. And we want to know how many times does the derivative equal 7/3? Well, if I go to my graph, this is the graph of my derivative, and 7/3 is 2 1/3. And if I draw that line in there, the derivative, the graph of g prime equals 7/3 2 times. So therefore, for part C, for part C, we would say 2 times as g prime of x graph intersects horizontal line y equals 7/3 twice. Okay, in the last example, or last part, it says on the x, find the x coordinate of each point of inflection on the interval 0 to 7, justify your answer. So again, if we take a look at our graph of g prime, the second derivative is undefined at 2, at 4, there's a small little cusp there, and at 5, but I only get a sign change at 2 and 5. So my inflection points for part D would be at x equals 2, because g prime changes from increasing to decreasing at x equals 2, and at x equals 5, g prime changes from decreasing to increasing at x equals 5, and those would be my 2 inflection points. All right, we've got a couple more examples to look at here. 2011 exam was a fairly tough exam, and we'll find out as we move through it. They have stepped up the difficulty of the question here slightly. So in this example, we're given a function g of x defined as 2x plus an integral, and we want to find g of -3 and g prime of -3 as well. So in part A, g of 3, all I'm going to do is I'm going to, g of -3. Just change that. G of -3, I'm going to plug -3 into my function. So it's going to be 2 times -3 plus the integral from 0 to -3 of f of t dt. So this is going to be -6 minus the integral from negative 3 to 0 of f of t dt. So I switch my limits, so I have to include the negative. This is going to be negative 6 minus, if I go from 0 to, or negative 3 to 0, that is a quarter of a semicircle with a radius of 3. So it's going to be pi over 4 of my radius squared. So this ends up being negative 6 minus 9 pi over 4. So that's g of negative 3. Now, the second part of part A wants me to find the derivative of g and evaluate g prime of negative 3. So the derivative of g is going to be the derivative of 2x, which is 2, plus the derivative of the integral, which is going from a constant to x. So that's just going to be f of x. Now, if I want to evaluate g prime of negative 3, it's going to be 2 plus f of negative 3, which is 2. Negative 3 on my graph has a value of 0. So it's going to be 2 plus 0, which is going to be equal to 2. Now, question B was a little bit challenging. It says, determine the x-coordinate of the point at which g has an absolute max on the interval negative 4 to 3 and justify your answer. Okay, so our absolute max is either going to be at the endpoints, negative 4 or 3, or it's going to be at a critical number. And to find the critical number, we take our derivative, which was 2 plus f of x, and we make that equal to 0. So 2 plus f of x equals 0. So this critical number is going to happen when the function f is negative 2. Well, if I go to negative 2 and draw a horizontal line here, okay, that intersection point there is actually at 2.5, or when x is 5 over 2. And if you wanted to prove that, you could find the equation of the line, and you could equate the equation of the line with negative 2, and you'd find that the x-coordinate was definitely 5 over 2. So therefore, my absolute maximum is either going to be at my left endpoint, which would be at, I'll just make a table of values here, when x is negative 4, at the critical number of 5 over 2, or at 3. So if I was to find g of negative 4, that would be 2 times negative 4 plus the integral from 0 to negative 4 of f of t dt. So this is going to be negative 8 minus, and I'm going to flip my integral around, negative 4 to 0 of f of t dt, which is going to equal negative 8 minus, okay, if I go to my graph, this is another quarter of a circle, okay, and it's below the x-axis, so it's going to be negative pi over 4 times the radius of 1 squared, so negative pi over 4 times the radius of 1 squared, plus, if I go from negative 3 to 0, that's going to be pi over 4 of 3 squared. So this ends up being negative 8. This ends up being 8 pi over 4, which is 2 pi. So therefore, g of negative 4 is negative 8 minus 2 pi. Okay, so now if I find g of 5 over 2, it's a bit of a process here. So g of 5 over 2 is going to be 2 times 5 over 2 plus the integral from 0 to 5 over 2 of f of t dt. This is going to be 5 plus, now I'm finding the area from 0 to 5 over 2, so I have a triangle here, and I have a triangle below. So this is going to equal, well, the base of this triangle is 1.5, or 3 over 2. So it's going to be 1/2. The base is 3 over 2, and the height is 3, minus, my other triangle has a base of 1/2. The base of this other triangle is going to be 1, and the height is 2. And since it's below the x-axis, I have to subtract it. So if I work this all out, this works out to be 5 plus 9 over 4 minus 1, which ends up being 4 plus 9 over 4. And if I want to find g of 3, okay, and I believe we evaluated g of 3 in part A, and no, sorry, that was g of negative 3. Well, g of negative 3, if we look at the graph, it's going to be more negative area because it's from 5 over 2 to 3, it's below the x-axis, so it would be subtracting more area away. So we know that g of 3 is going to be less than 4 plus 9 over 4. So therefore, my absolute max is going to occur at 5 over 2, and it's going to equal 4 plus 9 over 4. Okay, now the last part of this question is there's two more parts, sorry, part C and D. So part B did take a while. For part C, to see what it says, find all values for which the graph of G has an inflection point, give reasons for your answer. Okay, so inflection points are going to happen where G prime or G double prime is 0 or undefined, and G prime changes from increasing to decreasing. Well, I have one place where my function does not have a derivative, and the derivative is undefined right there. So for part C, we can say that we have an inflection point at x equals 0 because G prime changes from increasing to decreasing at x equals 0. And finally, in part D, they're asking us, find the average rate of change on the interval -4 to 3. There is no point C for which the derivative is equal to the average rate change. Explain why this statement does not contradict the mean value theorem. Okay, so for this particular question, the first thing we want to do is find the average rate of change of f on the interval -4 to 3. Okay, so this is going to be f of 3, minus f of -4 over 3 minus -4. So f of 3 on my graph is -3. F of -4 has a value of -1. So minus -1 over 7. So this ends up being -2 over 7. Is my average rate of change. And the question says, explain, there is no point C for which the derivative is equal to the average rate of change, and explain why this statement does not contradict the mean value theorem. It's because f is not differentiable. That is why it contradicts. The mean value theorem doesn't apply. So the mean value theorem does not apply to f, as f is not differentiable from x equals -4 to x equals 3. Okay, the next question, I'm going to have you guys do this one as part of your assignment. Okay, so the question in your handout will be part of your assignment. And there's some assignment from your textbook. So that concludes the first part of 5.4, and I broke it up into 2 videos because each video is quite long. So if you have any questions, feel free to ask me in class or go back and rewatch the videos.